Today we are going to discuss the problem 1301, that is number of paths with max score. So we are given a square board of characters, and and the character is marked as S at the bottom right here, like this, and there is a int at the top corner, right, top left corner, and rest all is either filled with uh, digits that, that is 1 to 9, or it is filled with obstacle that is X, a character that is X, which represents the obstacle, right? So so we have we are we have given, so we have to return two integers, that the first integer is maximum solve numeric sum of all the characters that we collect from going from here to here, right? And we have to return the uh, number of ways to get the maximum sum. So, if suppose if maximum sum is 5, so how many ways we can travel from this starting point to this end point with sum as 5? That will be the maximum in the number. So, for the first example, that is here, the sum is given as 7 and number of ways is 1. So, starting at here, we have two ways, three ways. Either we can go to up, right, or we can go to the left, or we can go to here, the diagonally, right, diagonally up left. So since we have given the option, right, starting as cell, we can go to this cell, and this cell, right? And since we have option, so the first thing that comes into our mind is recursion, right? We can break it into sub problems, right? We can solve for this cell, and we will give the recursion to find out the answer for the rest, right? So the very intuitive way, when we see recursion, and when we have options, so the first is the very intuitive idea is to apply recursion, and when recursion has this more than one option, then we can also memorize it, and that's leads to DP, right? We can apply DP here. So we will see. So here in this problem, so let's see how we can do that. So for a given answer, what will you store? So we need to track two things. That is, we in our for recursion, what the cell needs the information, right, to actually decide to which cell to take up. First is that the sum to sum that will this cell will give, and plus, and the number of ways to reach at that cell, right? How many ways we can reach up to this cell from this path or any path. So uh, what it will store, that is the sum plus number of ways to reach at the cell. So initially we have no cell, right? Initially we are if we are at starting, initially we having zero sum, and number of ways to reach that cell is with zero sum is will be 1, right? So it will be 1. So there is one way to if we are starting this, so there will be one way, right? And further we can explore. So first, this is the bottom of DP, but we will just discuss the recursion for the easiness, right? So in the recursion, we start from here and we'll explore, we'll get all the possible sum for the all the three options, and we will check if there is some way, if it is not zero, right? Means there is some way to reach to the target, that is E here, right? If if it if it is returns, so if this cell, right? If this cell returns something, that if there is a way, then we can consider this sum, right? And we will for all there is, if there is a way to reach to the end, right? So we will consider their sum and we will find out the maximum sum, and whichever the maximum sum is there, then we can uh, just add up the number of ways. So suppose if the maximum sum is 7, right? So if the maximum sum is 7, so we will just store 7, and uh, if they if it is giving 7 and this is also giving 7, and this is also given, what is the value of this? So it is contributing 0 at the starting date, and how many ways we can form, that is the summation of all the ways, right? So we'll sum all that. So let's see, go to code and see how we'll write this. So so this is the starting. We are making uh, a DP of n size, right? N cross n, and we are calling for the n minus 1 to n minus 1, that is bottom left, bottom right cell, right? And and let's see, and if it is 0 or we reach at index, that is x, then there is no way, right? And sum will be also 0. So we return this is for the base, and the first is for the sum. So there is a 0 way. And if we reach at the end here, so the sum contribution will be 0, but we have reached the target, so number of ways to reach the target will be 1. And now we are checking for up, right? So if I minus 1 is greater, if we can go up and that is not x, so we can go and get the answer for that, right? And same we do for the left, right? And same we do for the diagonal. And now we'll find out the maximum value among all, right? So the first, the left, and the diagonal, that's first. So the maximum sum from all three options. And we check if the this option is giving up the maximum sum, and if there is a way, at least one way to reach there, so that if sum is maximum but there is no way to reach the goal, so it will not consider as answer, right? So there should be at least one way that we are reaching uh, in some way to the target with that sum. So we are adding the ways to our answer, that and same for we are doing for the left option, right? If there is a way, we are adding the number of ways, and and after adding all the options, if we get a one way, if at least one way to reach the target, then we consider, if it is a starting cell, so there will be no contribution, so the sum will be the maximum only. And if it is not the starting cell, so it will, and it will definitely a digit. So we are uh, subtracting minus 0, it give us the integer value. So we add that value to our maximum, and now then we return the answer, right? And we have simply taken a DP vector for the memorization of n cross n. We are starting from uh, -1, and we are checking that if it is not -1, So we are returning. So we do not have to recalculate, right? And here we are updating our DP table, right? So this is a very simple code. It is has mark, but it is very intuitive. Just we have to think that we have to store two things, that the sum and the number of ways, right? So that's all for today. So this is a simple recursion plus DB is a standard problem, that whenever we have options to go to left and right, and so this is a template we apply. So that's all.